We're going to continue with our introduction to statistics by talking about types of data. Now, a major use of statistics is to collect and use sample data to make conclusions about populations. I've mentioned before that it's really expensive to conduct a census, and it takes a lot of time to do that. So, using sample data allows us to cut down on the time and the money that's needed to conduct a study. So, when we're talking about the whole population, we use the term parameter. A parameter is a numerical measurement describing some characteristic of the population. And when we're talking about samples, we talk about statistics. A statistic is a number measurement describing some characteristic of a sample. So the study of statistics is really trying to estimate parameters based on statistics that we gather. When we talk about data, one of the classifications that we could give to data would be to call it quantitative data. When we talk about quantitative data, we're talking about numerical data, data that consists of numbers representing counts or measurements. So weights or ages, things like that are quantitative data. Another label that we could give to data is categorical data. Categorical data is qualitative or based on attributes. So this could be things that have names or labels. So favorite colors, gender, shirt numbers on professional athletes. Those are numbers, but they're really a substitute for names. They represent a name and not some numerical value. So that's a categorical data. All right. So within these two big overarching categories, quantitative data and categorical data, we're going to talk a little bit more about the quantitative data now. So when we're working with quantitative data, it can be either discrete or continuous. When we talk about discrete data, we're talking about values that are finite or countable. So you can assign a number to it. And that number, like, you're not like, oh, there's so many of them that I couldn't possibly count it. You could at least start counting, right? That's discrete data. Continuous data, on the other hand, is numerical data where there's infinitely many possible quantitative values that it can take. So an example of this would be lengths. So if I said that I was looking between 0 and 12 centimeters, it could be 6 centimeters, it could be 3 centimeters, it could be 1.5 centimeters, it could be 3/4 of a centimeter, and it could keep on breaking down. Any two values that you give me, I can give you one in between it. And that's the idea here. Continuous data, there's infinitely many, and we don't even really know where we would necessarily begin counting the possibilities. Now, another way of thinking about classifying data is to have 4 levels. We name these 4 levels nominal, ordinal, interval, and ratio. At the nominal level, these are things that are characterized by names, labels, categories. All right, so we can put a whole bunch of boxes out and we know which box it goes in. That's the nominal level. At the ordinal level, now we have data that, again, still fits into boxes, but the order matters. So things like alphabetical order, so like A, B, C, D, E, F, like course grades come that way. Or you might have like people lining up in line where you have first in line, second in line, third in line, fourth in line, those types of things, ordinal data. All right. So again, we still have boxes. We know which box it belongs in, but now it matters what order the boxes are in. However, doing something like subtracting one from the other, it's meaningless. So, like, it doesn't matter how far apart the boxes are, it just matters what order they're in. Our next level is interval level. At this level, we still have data that falls into boxes, and those boxes are in an order. But now the distance between them matters. So years fall into this category. The thing that interval level data still doesn't have is some kind of zero, which makes us like think that there's a total absence of something. So like in years, the year 0 was still a year. It's a meaningful entity. There's no starting point of 0 there, right? So a starting point of like some kind of natural 0, that doesn't exist for interval level data. We finally get that meaningful starting point 0 when we talk about ratio level data. This is data that can be arranged in order, the differences are meaningful, and it has a starting point. So the amount of time that you spend in class, 0 minutes spent in class is meaningful. You've spent no time in class. You can't spend less time than that in class, but you can spend more than that. So there's that meaningful 0 starting point. And the differences make sense and mean something. So again, just to summarize those levels, we have nominal, that are our categories only. So boxes, doesn't matter where they are. Ordinal, again, categories, but there's some order to them. So now we have the boxes, but the order matters, but it doesn't matter how spread out they are. Interval, the differences, but there's no natural starting point. So again, we still have the boxes, but now it matters how spread out they are, but there's no like, this is where the boxes have to be to the right of. And then finally, ratios, all right, where we have a starting point where all the boxes have to be to the right of that, and it still matters how far apart they are and all of that, all right? So those are our 4 categories of data. Some other things with data that you'll probably hear at different points is people talk about big data. Big data refers to data sets that are so large and so complex that their analysis is beyond the capabilities of traditional software tools. Your laptop that you're using can't deal with this data set. All right. Analysis of big data, it requires software simultaneously running in parallel on many different computers. You have to have supercomputers involved to deal with big data. We won't be dealing with big data in this class. All right. Another term that has data in it that you've probably heard floating around at different points is data science. You might even know a person who considers themselves a data scientist. What data science does is it combines statistics, computer science, and software engineering, along with different applications like sociology and finance, brings these fields all together to study problems and suggest solutions for them. Now, when we have data missing, which is a really common thing, we talked about it a little bit last time, but we'll talk about it a little bit right now. Again, if the data is missing at random, then that means that it's no more or less likely to be missing than any other data value. This is something that happens when someone forgets to answer a question on a survey. Not like the question on the survey that people are skipping because they're not comfortable answering it, but the question that they just forgot to answer. That's missing completely at random. Missing not at random is when a value is related. It's missing for a reason. And this is the type of thing where you just might not be comfortable answering that question, and a lot of people might not be. And so that question is skipped, is missing more often than others. So it's not so random anymore. When something is missing not at random, there's things to be learned there. If it's missing completely at random, it's not necessarily a big deal. And there's not necessarily anything to learn, it's just an oversight. So when we have missing data, since we can't really necessarily interview the person to find out all of the psychology behind the missing piece of data, we determine whether it's missing at random or not. And we decide how to deal with it, how to correct for it, based on what we learn in that analysis. One option that we have available to us is to delete cases. This is one of the most common things that we do. If we have enough total responses that we can just delete all the subjects that have any missing values. So anybody who made the mistake and skipped a question, we just don't pay attention to their responses. Then we do that. We'll delete all subjects that have missing values. Now, if your sample size isn't large enough to make that a really viable option, sometimes we do a thing called imputing missing values. When you impute a missing value, you're going to substitute a value for it. And there are various techniques available about how we best can replace that missing value.